Okay, hello, everyone. It's interesting hearing that people were finishing their nights. It is delightfully right in the middle of the day for me at 12:30, give or take, here in Australia. So, over the next 25, 30 minutes, going to be talking a little bit about BDD, Shift Security Left, and also Terraform for some good measure, because this is Hashi Talks at the end of the day. All right, we'll kick off with two key takeaways that hopefully, if you remember nothing else, hopefully you can remember these things come the end of me talking. So, the first, that BDD is about communication, and sometimes in security, we forget that communication is an important thing. And second, that modules, and I'm talking Terraform modules specifically here, they should be deep, not wide. And I'll get into what I mean by that as we go. So, I already had a bit of an intro. I wrote the Cloud Native Security Cookbook with O'Reilly that came out last year. There is a ridiculous amount of Terraform in that book for all three clouds. HashiCorp Ambassador, AWS Ambassador. I like to run my mouth a lot, so I do a lot of conferences and I write in random places. So, BDD. I've been doing BDD for a number of years now. I used to run workshops teaching it. I've done a lot of technical delivery using it. And it's a tool that I hold really close to my heart and something that I wish more people knew how to do well. A lot of people know how to do it in theory, but sometimes the actual execution falls away a little bit. And I'll talk about a couple of the really common anti-patterns that I see as we go along. For people who aren't overly familiar with BDD, it's effectively the combination of a specification and some automated tests, and you end up with a specification that is inherently executable. So rather than having the delightful thing where something is written in Confluence and you have tests checked into your version control, this is trying to bring the two things together. So your documentation is something that actually runs your system and allows you to test. When you look at this, and especially from a security point of view, you end up with, well, who are the people that are going to read this executable specification? And you actually get to the point of there's actually a lot of different people that might read it. Security teams, delivery teams, auditors, platform teams, product owners, and that is not an exhaustive list by any stretch. This is a lot of people who look at the world in very different ways and have different ideas and skills. So this is where potentially BDD, with the fact the specifications are in generally English, but doesn't have to be English, can be any kind of language that you want. It helps with that communication piece. You can actually write it in a way that everyone can understand and not someone with a particular understanding of some kind of language. And I'm going to pick on HashiCorp Sentinel here slightly, but although it's a great tool, this is where the trade-off comes in. So let's say we have a new compliance requirement, mandatory tags. Now, if you work in cloud, this is something that always comes along. Everyone always wants to tag all the resources. It's often done very badly. I think the general rule of thumb is if you've got 80% of your resources tagged properly, that you are right at the top end of where anyone possibly is. But in what we try and do is we normally write compliance rules to try and enforce these tags. So on the right is an example of how you could try and do this with Sentinel. Now, I mean, I've been working in tech about a decade now. I can look at that and read. I can understand what's going on, but it's not trivial. It's not easy. It takes a bit of effort to understand what's going on, right? And if I was to give this to a non-technical person, can they understand what this is? 100% no. They might get lucky, but generally no, right? Is there something we can do if we take from the BED kind of wheelhouse? Can we do a little bit better? Okay, if we were to take that same requirement and convert it into an executable specification as in BDD, it would look something potentially like this. And this is one I took from an example of stuff I did at a client a couple of years ago. This is very easy to understand. It's very plain English. It's really kind of simple. And I can see, okay, I need certain tags. I need owner, cost code environment, pretty typical tags that go on resources in AWS or any other cloud for that matter. Okay, and then if I want to extend this a little bit and I get to, okay, well, actually, I've got specific values I want to do. When I looked at Sentinel, I wasn't even able to do that for a start. And when I look at this, I'm trying to understand, okay, what tag values are appropriate in here. Now this becomes quite obvious, right? Like this is very easy to understand. Okay, owner either has to be Joshua Beck, cost code can be one of a few, and environment can be one of a few again, right? Like it's very easy for someone to look at this and I get this, right? It's not hidden behind some arcane language or mystery errors or all this kind of stuff that gets thrown at you, right? It's something that's just, okay, I get it. This is easy, right? And when you've got a team that's trying to enforce compliance and shift security left, and it's one team trying to get this with 100 teams, and in my professional experience, I work mostly with enterprises where we are talking tens to hundreds of teams. I need to be able to communicate this in a way that they can readily understand. Not, okay, well, if you learn the language I've written this in, then you can understand what I'm trying to tell you, right? This is something that enhances that communication by making it easy. And I said I would talk to a little bit in terms of the good patterns and anti-patterns that I've seen in BDD, having done it for over 5 years now. One of the big ones is many small tests over fewer larger tests, and I'll get to that in a second. And then I'll get to writing scenarios across functional activities. This is not something that someone needs to go away into a corner and write by themselves. This is a collaborative activity. And third is these tests should be gates on pull requests. If you're not passing these tests, why can you merge the broken code? That just doesn't make sense, right? And that's how you can get the enforcement on here, is by making it so it lies between your development branch and the shared branch of mainline. So big tests, they lose clarity of intent. That's kind of the big problem with them. It starts to get really hard to understand that if this test fails, what's wrong, right? In this example, it's got to have tags, it's got to have an instance profile. The instance profile permission should be restricted. It must be of an approved machine type, and it must be using approved AMI. If this test fails, it's now harder for me to figure out what's going on, right? The test is trying to do too much. There are too many assertions. This gets really hard. Often, if you have existing manual test scripts or manual compliance controls sitting in documentation in Confluence or similar, and you convert them into BDD specifications, it will start to look like this because people will see it as a checklist that they have to check against, not a series of tests that should fail for one reason and one reason only. The second bit is around this collaboration idea of who should be here to build these tests. How do these tests get written? And the general approach is with what is often called three amigos. So a product owner and two engineers would get together. So product owner in terms of owning the compliance standards, and two engineers who are capable of implementing the specification. You need three people in here to get a variety of viewpoints and not have something that makes sense to one person, but whenever you try and give it to someone else, they have no idea what's going on, right? If you look at DDD and trying to build ubiquitous language, this is done through sharing and communicating between people, not doing it in isolation. And the last bit is this: I have PRs. I want to prevent people from being able to deploy non-compliant stuff into production. So you can have a central compliance test repository that you can check out via GitHub, which is the most common style of doing this. You could use GitLab or any kind of other version control. That gets checked out dynamically into continuous integration sessions. And then you can make sure that you are compliant to the latest set of controls, not just the controls from a month ago or 3 months ago, but you're right there on the cusp of exactly what you need to be compliant against every single time you go to merge any code. When you get to the point of BDD in this space, you have the prevention. Normally, when you talk about controls in the cloud, you kind of have three. You have prevention, detection, remediation, or correction. Prevention is the one that stops the rot. It makes it so things don't get worse. It's fundamental for trying to make things better is that you stop people making it worse. Because generally, as I was kind of talking about, you normally have one security team that is interfacing with multiple delivery teams. You're outnumbered. You need to be smarter about this. You can't go and fix the mistakes. You need to prevent them in the first place. And if you start to wrap all three kinds of controls in code, that's when we start talking about compliance as code. This is something that has come a long way with the cloud, with the speed of delivery. It opens up this as an option, in which case you can have compliance as code, not living out in documentation somewhere that people have to read, but something that's executable that drives the behaviors fundamentally by getting in the way. If you want to explore what BDD and compliance with Terraform can look like together, there's an open source tool called Terraform Compliance, which is where I took those examples from, written by an old colleague of mine. And Cucumber is the place where everyone goes to learn about BDD. They are the company that does the most with it. They produce most of the open source tools for it, and they have some really good training on it if it's something you haven't done a lot of before. So in that first half, we kind of talked about prevention in terms of stopping things getting worse. What I want to go and talk about now is how you can use Terraform modules to actually accelerate teams to move faster, as opposed to just getting in their way all the time. So, module design. This is an interesting and very opinionated topic. What I'm going to talk about is module design in the context of an enterprise. So this is private modules, not public modules. Public modules have quite a different set of constraints and ideas. This is how you do private modules in an effective way. Modules done well enable secure by default. So when we're talking about all these rules and controls we want to implement, we can actually use modules to abstract that away, take cognitive load off the teams, and make it so all these tests they have to pass, if they're using modules, they just pass them by default. Everything is easy. They can move faster. You know, a classic one in here, enforcing least privilege for KMS keys. Now, this is a classic problem I see in many, many enterprises or many companies using the cloud. They use KMS in AWS, in GCP, in Azure. Maybe they use Vault. But fundamentally, the way they write the policies means that a lot of the time the encryption is nowhere near as strong and robust as it should be. The easiest KMS key policy to write is one that I don't have to because someone's figured out what it needs to be for me ahead of time, right? When you're looking at trying to do these abstractions, you want to take pain and effort off the teams. One of the really hard problems to solve is how do you actually achieve product market fit for modules? It's very easy to write a Terraform module. It's much harder to write a good one, and it's even harder to write a good one that gets used by a lot of people. And really, when you're thinking about writing these modules as a platform team or a security team, who are your users? They are the delivery team, they're developers, right? And as much as security people often disparage developers, I think as developers, as lightning is one particular analogy I like to use. They want to go the path of least resistance, right? They want to go as fast as possible. That's how they're incentivized. That is how they're told to work. So if you can make it so going your way is also the fastest way, they will naturally come along with you on that journey, right? As I've been saying, modules are an abstraction. Now, one of the problems that I've seen with this is developers we come up against abstraction all day, every day. We're trained how to do it. We're very much trained how not to do it. And we start to understand the trade-offs you're making when you try and do an abstraction and kind of what makes a good abstraction. And I'm going to get into a little bit more detail of one way of thinking about that. Operations people, unfortunately, due to their experience and their background, haven't always had the same learning curve. They haven't paid the same blood debt almost of the pain of a bad abstraction, which makes it then very hard for them to write good abstractions. So that's where we kind of need to think, well, what can the developer community tell us about how to do infrastructure? Because we should be sharing and learning from each other. Fundamentally, a good abstraction reduces cognitive load. That's kind of the best measure you could possibly have for one, is an abstraction means I have less to think about. And when you look at a Terraform module or an abstraction, you can say, oh, this is a deep abstraction, or this is a wide abstraction. And when you look at this, the green bars are how much I need to understand to use the abstraction, right? And when I'm saying that ideally a module reduces cognitive load, this resistance to using the module, if I have to spend a day learning everything about it to use it, something's gone fundamentally wrong. If I can use it quickly and just go, oh yeah, this is obvious, I know exactly how to use this, there's good documentation, all that kind of stuff, then there's a lot less resistance to working with it. Now, when you look at what constitutes a public interface for a Terraform module, it's the variables. That's the public interface. That's the options. That's what you've exposed. That's the equivalent of the parameters passed in the function call in the programming language is the variables, right? The problem with variables, and this is a classic problem I see with modules, is when you start to go, okay, well, I have a couple of variables, I have 5 variables, they're all binary. There's 32 different ways of doing that. If I start expanding out exactly how many variables I have, you quickly end up with permutations in the thousands. There's thousands of different ways this module could potentially be done. And this is based on the idea that variables are binary. In reality, they're not. They're multivariable. Like you can have maybe an enum of different kinds, open string or whatever else. The more permutations your module can have, the harder it is to understand and the harder it is to be sure the module does what you want it to do. If there's 1,000 different ways someone can use your module and different variables they can flick on and off, now it's very hard for you to produce a module and know that it's going to work, right? The more permutations there can be, the more chance there is that one of them is going to break or be broken, and that in then will break the trust that the delivery team has in you as the person who wrote the module. And really, at the end of the day, you want to have that strong level of trust between the teams because that's how you work together. If they can't trust the modules you're producing because they have bad experiences, you're going to have to fight really, really, really hard to get them using them again. In which case, this whole point of abstraction starts to fall apart because no one uses them because they're not there. This is classic product market fit considerations of how to build something that people want to use, will use, and will continue to use. I often look at the number of variables as a heuristic for module quality. If I have a lot of variables, I probably think it's normally in a private module, not very well designed because it's trying to do too much. It's trying to cater for too many people. One of the classic things that when I have a debate with someone about module design is like, oh, but what if someone needs to do this? And I'm like, well, who has told you that they need that? And they're like, oh, but they might need it in the future. I'm like, okay. When we get there and someone asks for it, we can extend the module to include that. When you're doing private modules, you want to build them for today, not tomorrow. Just look at the requirements you have today. Don't try and think about 3 months or 6 months in the future because none of us are that smart. None of us can see the future. And you're complicating the module. You're making it harder to use, more likely to break by trying to extend it to include features that no one's even asked for yet. How else can you reduce resistance? I keep coming back to this point of you want trust, you want people to be able to use these, you want modules that are going to support people actually move faster and be more compliant and more secure as you go. Solid documentation, classic one that's always talked about, but thinking about the documentation, videos, this is something that HashiCorp is known for, is the quality of their documentation, right? It's one of the key things that makes the tools a delight to use. The documentation is so damn good. You should be taking the same approach here, not just going, oh, but they know how to use Terraform, there's a variable file, this is fine. But what more can you do? Another one is invest into teams. So when you're building these modules, don't build them in isolation. I was saying isolation from a person in a corner. Don't be a team in a corner either. You should be talking with the people who are using these modules and building it with them in mind, very much like an Amazon work backwards kind of approach. You need to be investing into teams. Again, this builds that foundation of trust that's fundamental to working together. And the last one is commit fully. At the point where you create a module, you should be willing to subscribe to the maintenance of that module for an extended period of time. Don't throw something out there that you're unwilling to commit to maintaining, right? Again, it comes back to trust. If you go through and you create it and then they have a problem, you go, well, that's your problem. That's not my problem. Again, you're breaking this fundamental basis of trust, this foundation, and then you're going to have problems convincing them to come along with you on the journey later, right? If building trust and finding ways to work between teams is very effective, or that's a problem that you currently have. There's a fantastic book called Team Topologies, which is probably one of the most transformative books around inter-team interactions released last 5-10 years. They have this model for building shared understanding in there. The rest of the book is fantastic. This is one bit I steal a lot. And it talks through the stages of making something as a service. So first you can collaborate with a team. You get in there with a team, you own the outcome, you work on it together. Potentially, once you've got that understanding from that team and you know what's going on, then you can go to, well, then we can go to a facilitation mode now. We can help other teams use this, but we don't need to get as heavily involved anymore to drive this forward. We think we understand the problem well enough, and we have a solution that's mature enough that will need to be there to help, but we don't have to drive anymore. And ideally, from many things, you hit this third stage, which is as a service, which is, for example, you have a Terraform module used by a bunch of teams that is, well, it's battle hardened. It's been used in lots of places. People know it's very solid and they want to use it. In which case now, you know, teams can go self-service this. They don't need to come to you for support anymore. Ideally, eventually, once a module is used by many teams, they will support it themselves, extend and maintain it themselves, because they have a vested interest in it. But you have to build that initial layer of trust, get them using, get them invested to the point where now there's a bigger cost for them moving off the module than just sticking with it and maintaining it. So if these kind of concerns are things that you have or problems that you have in a day-to-day, I've just thrown 3 book recommendations in here because I'm terrible for always giving people book recommendations. The first one is Software Engineering at Google, which talks about Hiram's Law, which on that point of permutations and all those kind of things, that with a sufficient number of users of your interface, they will use it in a way that you've never even thought of before. There will be use cases you haven't catered for, that you haven't thought about, that exist anyway. And fundamentally, at that point, it gets very hard to make any changes because you might break someone that you never knew was there in the first place, right? The concept of deep versus wide abstractions comes from a philosophy of software design. There was a second edition that came out last year by a professor of computer science. It's great as a deep look into how abstractions work and how you should think about them. And team topologies I've kind of already talked about. If you're looking at how to structure teams, how to work within teams, how to best support like digital delivery at scale, there are few better resources than that book. And I'll just end with just coming full circle back to the couple of key takeaways. The first is that BDD is about communication. It's not about testing. But this communication layer on BDD can be very valuable applied in the right contexts. So when you're looking at these compliance concerns and you have many consumers of the tests, potentially adding BDD is a really useful value add and layer on top. And the second is that modules should be deep, not wide. You want to make it easy for people to use the modules. You want to make it so they rarely break and you can build this level of trust, because that's how you can build an ecosystem and a culture that makes use of them, and not have this constant divide between the teams where you're building stuff and no one wants to use it because they've learned not to trust the things that come out of that team in a previous life. Even if the new stuff is good, people have a memory for the things that didn't go so well. And that's the end of the content for today. I'll hang around on YouTube for questions, or you can find me on Twitter, LinkedIn, all those kind of places. And please do ask me any questions that you have. Thanks.